Hello everybody, my name is Jean Marie Verdun. I do work at HPE within the Advanced Development Engineering team based in Houston. So I will be covering during this short talk the status of Linuxboot on HPE platform and where do we stand. Just to support Linuxboot, we have to understand a couple of challenges that a company like HPE is facing. The first thing is we are developing our own BIOS. So everything is made in-house, and we have a lot of legacy within the source code and within the application. So we developed that system BIOS for about the past 20 years. That is a strong competitive advantage, we believe, because we can control the bug fix. But it does involve and imply a few challenges that we have to overcome when we speak about open source firmware. The first one is our system BIOS code is tightly coupled with our BMC code. So which means that the day we will be supporting Linuxboot, we have to change either the idle source code, which is the standard HPE BMC code, or we have to switch for an open BMC application on the BMC. We have a lot of legacy drivers which are included into our system BIOS, and I will be discussing a little bit more later on during that talk. And we ship that solutions on millions of servers, so which means that the code quality must be very high, and we need to test everything just to be sure that we are not breaking critical systems around the world. So, and as the last steps, we have to support multiple hardware architecture, which does include Intel and AMD. So all of these challenges needs to be overcome before we can ship an open source firmware solution on top of our platform. We started that work about 1.5 years or 2 years ago, and this is progressing into the right direction. We do have a working proof of concept. Let's discuss about that. So we started with a port of OpenBMC, and this is currently done and published. And our main goal is really to open source everything which is related to our platforms. And you can go on our GitHub repository, which is pointed out within that slide. We untied within that port the system BIOS from the idle firmware. And this has been a lot of work. And we are currently copying the system ROM into the RAM of the BMC. That is an important behavior because within the HPE ProLiant hardware infrastructure, the system BIOS by chip, which is the flash which does contain the code for the host systems, is directly connected to the BMC. It's not connected to the PCH, and we needed to take care about that. So that's an uncommon system architecture. We have an initial Linuxboot port which is working as a UEFI shell replacement. It is done and published, so you can go directly within the Linuxboot GitHub repository within the mainboard repo. And we started to remove what I call useless drivers or very old legacy drivers. And you can also have a look to that directly within the GitHub source tree. As a second step, we are working currently at addressing some issues that we are facing with Silicon Root of Trust and Intel Boot Guard. So HPE platforms are coming with a Silicon Root of Trust, which is sealing directly into the BMC, and this is a very important security features that we wanted to enable also for open source firmware, and that required that we build up a chain of trust. And this took us most of our effort during 2020. We are also working at generating a proper UEFI shrink down version of our system BIOS as a binary blob that we can use below Linuxboot. And we are expecting and we are trying to ship Linuxboot as a shell replacement for UEFI on our system as a first step. We would like to provide also enhanced end user experience by allowing SSH to the system BIOS and the BMC, and we added these kind of features, and we will be seeing that during our short demo. The key thing there is really that we are open sourcing everything, and our early adopters, so we started to sample systems to them, are private customers which are able to recompile open source firmware. So that is one of the primary reason why the offering is currently private. but it doesn't mean that you cannot get access to it. You can get access to it as long as you are able to recompile your firmware. So I have a short demo to introduce you. So that demo is based on the OSFC software stack that I'm currently developing at HPE. So this is the workflow that we are using. And this is a web interface. And from that web interface, you can select a GitHub repo with a branch. So I'm going to use my own GitHub repo, so which is Jean Marie/mainboards. And I'm using the branch called keys. I can build my firmware image from there. So let's start to build a Linuxboot image. So the system is going to clone the repository and is going to execute the build-up. And the output of that is a Linuxboot image. At the top, you can do the same thing for OpenBMC. So regarding that demo and due to time constraints, I'm using a pre-built OpenBMC image, but you could be specifying there an OpenBMC repository with a various branch and rebuild it and load it directly to a flash emulator, which is directly connected to a running system. So this is based on uroot, and this is going just to integrate an SSH key directly into a Linuxboot image, which is going to be running on top of a DLC60 Gen 10 systems. So the build time is normally short. That's going to be less than 5 minutes. And when it will be done, so the output is going to be a fully functional ROM if the build is okay. When it will be done, so I can load the firmware and I can decide to install an operating system on the live machines. So right now it's building the Linux kernel, and this is then going to inject the the init.fs into the Linux kernel. Then it will be introduced into an HPE ROM. So right now you cannot download the output of the compilation from that tool, but this is going to be enabled within a week or two, and you will be able just to generate your own image directly from the tool. So the image is saved. So we are removing the unnecessary Dixie now, and then we will be getting the output. There is a last trick within HPE image, so they have to be shadowed. So it means that we always have two working flash version within the SPI flash. So that's why we shadow the image at the end of the compilation. So it is done, so I can load the firmware to my flash emulators. So this is going to be done there. So we are using EM100 flash emulators, which are directly connected to a SPI bus of a physical system. So that's a 64 meg image, even if the generation of the image was 32 meg with the shadowing process. So when it's done, I can turn on the power, and we can see there the console of the BMC. So this is a BMC which is based on the GXP ASICs from HPE. So that GXP ASIC is a single-core ARM processor, and this is embedding a silicon root of trust. It's able to run a U-boot, and this is going to boot OpenBMC. The boot time is a little bit long because the core frequency is low, and we're running with 384 megabytes of main memory, and it also has to run a full copy of the Linuxboot image into the RAM of the BMC. So when the BMC will be booted, we will be able to connect to the OpenBMC image and get access to the Linuxboot system, which is running on the host. So let's give us a few minutes just to get it up and running. So OpenBMC is a great tool, but it is taking a lot of time to boot. So this is just my current feeling with the solution. So everything goes smoothly currently. So what else could I add? So right now for OpenBMC, we are able to sign U-boot image, and we are able to use a public key just to sign the the remaining part of the image, which includes the Linux kernel and the file systems. So this is providing security. And the way we boot up the BMC is through a tool or a small binary blob that we call GXP loader. And that GXP loader is signed through an HPE key, which is properly recognized by the Silicon Root of Trust. So the BMC is up and running, so we can connect to it, and everything is done interactively. The test system is based in Houston, Texas. So depending on where you are, the latency could be a little bit long. So the BMC is up and running. I can now click on the BMC web interface. So I should be redirected to the BMC, and that is the case. And I can now connect to it. And if I go to the control area of the BMC to the serial, so we can see that the server is currently powered off, and it is going to be turned on probably within the next couple of seconds. If I get back there, we can see that there is probably a DD. Yeah, there is still a DD there, which is running, and that is the copy of the Linuxboot image in RAM. So as long as it is not finished, the host is not turned on. So the copy is now finished, the host is turned on, and if we are lucky, we will be seeing a Linux kernel booting up on the serial console right now. So we just have to wait for the Intel memory reference code to run the low-level UEFI system to bootstrap the machine, and here comes the Linux kernel. So with the Linux kernel booting up, we can now have a look to a few things. It's up and running. I can start the HC client, which is going to request for an IP address on the 4 Ethernet cards which are available within that machine. So I'm getting one, which is just right here. I can go to etc SSHD and run SSHD from there, and I can SSH to this IP address directly from this machine. So let's try to do that. Okay, this is complaining about the fact that SSH configuration has changed, and now I can connect. I am connected to my Linuxboot image directly to my server, and this is just great. So I can now boot the machine, and I can boot Ubuntu. So as I'm going to boot, the SSH configuration, the SSH connection is going to be turned off, and I can get back to the console and can see the Linux kernel from the Ubuntu distribution, which has been pre-installed on that server's booting. So from an end user perspective, we got a fully working stack right now, which is a proof of concept. But we are improving the code quality on a daily basis, and we are pretty optimistic on the fact that 2021 might be a great year for open source firmware. So the OS is booted. I can log into it, and this is just working pretty well. That's it for this demo. I hope you enjoyed it, and I wish you a great conference.